Hi everybody, welcome back to Goju Tech Talk. Today we are going to talk about a little bit more on how you might build your own video game. And in particular, we're going to look at two fundamental questions or discussions. The first is around software architecture and software design decisions. In principle, the programming languages that we might choose for our video game, as well as data languages, which I think are some hyper important fundamental decisions you're likely going to have to make. So let's spend a little time on that today. On top of that, we're going to take a look at the Goju Tech Talk thumbnail generator and see how that has progressed, which is actually part of the reason why we got into topic 0. And maybe I can quickly start with that to help us understand how the update here is getting us back to this question. Okay. So let's take a look. Here's our Goju Tech Talk thumbnail generator. And just so everyone knows, I might change the name of this channel just to be Goju Tech. I'm not sure, just because GTT is feeling a little long. I want to go a little shorter than that. So maybe it'll be GT. We'll see. If any of you have ideas, feel free to drop something in the chat. Mostly just shorter is better. I was thinking Goju Tech. Maybe that gets to the heart of it. And I realized that we talk about things that are not all tech. So I was kind of thinking, what about Goju Talk? But then I love tech. Anyway, you can imagine how I'm at least marginally conflicted on this. Okay. So how did we get to things like programming languages and data languages? Well, how we got here, essentially, is I was vibing away on this thing, trying to deeply understand vibe coding, its strengths, its weaknesses, all that stuff. And by the way, I may fiddle around with Cursor next, or the Claude code thing. But I think that for the purposes of what I'm trying to demonstrate, I'm trying to get a sense of what's possible with the code assistance, principally through a natural language type of interface, at least right now. And I feel like Gemini's Canvas is a pretty good place to get us a sense of things. Now, as this thing is getting more and more complex, I've noticed that it's taking quite a bit longer to then add features. And I'm starting to get in the weeds here on a number of things that you can do. So you can see these up and down votes on these things. They exist here. We have the control keys, the arrows, as well as the hover over for the mouse. And at startup now, what will happen is it'll generate an entirely new meta prompt. And so there's stuff going on. Now when you save the images, it just zips it all and saves it into like a single file. I'm still struggling with certain things like getting these images to be 4K or HD. It still wants to do just 1024 by 1024. That might be an API problem. I'm not sure. But now, as it's generating all this code, and it's taking longer and longer, I sort of got frustrated at how long it's taking, because it's taking maybe 10 minutes now to do the simplest, smallest update. So I started to look into this to try to understand like what it's doing. And what dawned on me is there is a ton of stuff in here that actually has nothing to do with the program itself. Like, here's the body, here's actually the code that's doing stuff, right? That is code that is executed to do various things. And you can see this code is getting pretty not super great. I'm going to extend this out a little bit just so we can look at this. So this generate images function, just following the whole never nesting idea. So we're 1 level deep, we're 2 levels deep, we're 3 levels deep, 3 levels, we're 4 levels deep, we're 5 levels deep, we're 6 levels deep here. I mean, this is what's going on here. This is too deep and too much code for a single function. So generate images is now 915 to, it looks like 1077, if I'm getting that right. Yeah, I think 914 to 1077, and that's too long in my book. And that's only one of the many problems that I'm seeing with this. The bigger issue that I'm realizing that this system is really struggling with is it's regenerating all of this CSS style related stuff every time. And that's very confusing to me, because for the most part, this data, which, by the way, this is data. This is not code in the sense. I mean, much of it is not code in the sense that it is executing. It's more things like setting layout, which is stuff that generally belongs in this space. I guess we'll say in this data space, we'll say CSS, cascading style sheets, XML, extensible markup language, JSON, JavaScript, object notation or something. But whatever these actual acronyms are, I think the important thing to understand is they're mostly data languages, which we'll get to. But given that these are data languages, one of the big issues that we have here, or that I have here, is we're having the AI churn on all this stuff each time. But for the most part, I'm adding new functionality to the system, which essentially has no bearing on any of this CSS stuff that's happening in the first, arguably, 350 lines of code, or lines of data. And a quick way to tell if something is data is one of the main giveaways, or a telltale, is it's not an instruction that would be executed that would have some sort of outcome that requires it to do these things serially. So, for example, you could take this top and put it at the top, and it probably wouldn't break anything. And you could take this width and move this width to the very bottom, and it kind of wouldn't change anything. As long as it's having a mapping inside of this wrapper, then that's all that kind of matters. But in code, in actual operations that are going to be executed, the order in which you are executing things will often matter quite a bit. So, for example, in this event add listener, this add event listener, when you are executing this without looking at this very closely, if I moved this handle file operation up above this file operation, this just wouldn't work, because file has not been defined. I'm not sure JavaScript might allow it, but essentially it doesn't have the right data unless this line gets executed. So if you just moved this up, you don't get the same type of consistency that you get with things that are related to data. And that's because when you're executing the individual lines of code in programming languages, the order in which you're executing those often has very real world and direct impact. So you can't just move things around arbitrarily like you could in the stuff that we saw up here, right? Like I can just move this border to the top and nobody's really going to care. And similarly, if we had a full-on JSON file that this is sort of mimicking, we would have the same type of behavior, same with XML, same with like text-based things. Which then leads us to one of these fundamental questions that we will likely have to ask ourselves when we're getting ready to create a game or any large software system. And those questions are principally around, there's many questions we want to have answered, but two that are super important are: what programming languages do we envision we're going to use for this, and what data languages? Now, the programming languages are going to be critical to the system that we use or the system that we're building, as well as the different environments that we're in, which we can get into. And so if you pick the wrong language for the type of game that you're trying to build, generally speaking, it's going to be a non-starter. In other words, you're probably not going to get very far at all. Like, it's just sort of not going to work. Whereas with the data languages, you can often get away with choices that you like personally, and as long as you don't get too crazy, this all relates to scale. In some ways, I think what I'm trying to say is you may have more flexibility in the data languages that you pick to support the data that you're going to need for your game, whereas you may have less flexibility in the programming languages. So, first, let's start with programming languages. Since we're talking about video games, I wanted to mention C, C++, or something else super fast. Now, for some of you, you may not love this. And you may be saying to yourself, well, I want to create a game, but I don't know C and C++. And because I don't know those two languages, I'm not going to use those, but I can just use something else. Well, possibly, but let's take a look at what Perplexity has to say about this and then go from there. So I asked Perplexity just now, what programming languages are most video games written in? And it comes back and it gives me this answer. And I have to say, based on my own experience, this is pretty fair-ish. I want to also share that the order in which it's listing these languages is, I think, not an accident. That a large majority of the games that exist, especially AAA titles or games that require extremely fast execution, are written in C++. C potentially as well, but C++, classes are your friend. And if you write it in C++ and you're writing C, you can always add classes and things afterwards. Whereas if you are writing it in C and not C++, and you start to do a whole bunch of C-ism type things, it might be harder to upgrade to C++. So in C++, the fundamental difference between classes and structs is the access modifier. And access specifier, the access specifier. And in C++, you essentially have these three. For classes, by default, I believe it's private. For structs, I believe by default it's public. Now, going back to what I was saying about writing it in C++, and then you can evolve it to be more C++. Let's say you use structs and you're not using classes. Well, essentially in C++, structs are classes. It's just a slightly different access specifier default. Whereas if you're in true C, I think that last I checked, C doesn't have classes, or it didn't when I was looking at it. So a struct really is sort of a struct. Why does that matter? Well, I think structs can't have methods because classes don't exist, but structs in C++ can. On top of that, if you're using just raw C, you don't have things like templates, and so you'd be forced to try to do generic programming, principally by using things like void pointers and other type of shenanigans, which might not be super great. So this is my argument that you should probably lean towards C++, even if you don't know it, and you know mostly C, is that you can be writing C-ism related things and then sort of gradually upgrade yourself. And this, I think, is probably a good mindset, because you probably, if you're going to build a game, my strong recommendation is you want to use a language that supports objects for all the reasons that we talk about with large-scale software development. Things like encapsulation, using contracts for APIs, things that are just going to make your life generally better. Now, when we go back to perplexity, we see the first comment is C++. This is the dominant language for game development, especially AAA titles. High-performance games, C++ is favored for its speed, low-level memory control, and ability to optimize performance, which are crucial for games with complex graphics, physics, and AI. Most major game engines, such as Unreal Engine, CryEngine, and Source, are written in C++. Even in engines that primarily use other scripting languages, like Unity with C#, have their core system built in C++. Also, I would probably make a slightly bold statement here, which is generally what I've seen is that if you can program in C++, and I mean grok it in the sense that you understand memory management, you understand pointers, you can create classes that have a good cohesion but are loosely coupled. You get all that stuff. You understand types, and maybe once in a while you have to dip down into assembly. You know, you're sort of just like walking the whole space. If you can do that, you can probably program in any programming language. That's right. Any language. And the reason why I say this is that what happens in C++ is you sort of are not like, there's very little that is hidden from you, that is done for you. So you have to really kind of understand the whole process. You have to understand memory management. You have to understand the way that members are going to be cascaded together in a class and how that impacts object layout and things of this nature, that a lot of normal developers, like people that are programming in higher level languages like JavaScript or Python, they likely don't know. And that can be okay. But the problem is that when you're working on something that is a game or an operating system or something that needs to run extremely fast, more likely than not, you have to do a lot of the heavy lifting yourself. That the heavy lifting can't generally be offloaded to other systems. Now, with that caveat, I will say that the next two groupings of languages that are getting us close to C++ would be C# and Java. I think that that's probably pretty accurate. My view of these two languages, and I've programmed in both these languages. Obviously, C++ is the language that I kind of eat, sleep, and breathe. But I have dabbled in both of these languages, and from what I've kind of gleaned is Java is, I think, really good. It's commonly used for enterprise software and spaces where you need really strong degrees of security and other things, where a lot of the heavy lifting of memory management and ensuring things are all kind of like buttoned up is done for you, which can be very useful in those spaces. But I think that because it is used for this sort of specific space and has these sort of hardened rules, it doesn't always give you the flexibility that you might need if you're going to do some really crazy stuff. Whereas C#, I think, does. Now, the trick with C# is C++ and Java, at least last I checked, are mostly kind of like open languages. I know this is not like totally true. The C++, I think, is maybe the most open in that it has a standards body, and it has ISO conformance, and there's different governments and countries that are involved in its oversight. This is all good stuff for ensuring that the language is not going to vanish or go sideways from some advancement. Java initially, as I recall, was created by Sun Microsystems, and then Sun was essentially acquired by Oracle, as best I recall. And when that happened, Oracle, I think, took ownership of lots of the IP related to Java. And some people argue that Oracle's acquisition of Sun Microsystems was mostly so Oracle could try to sue Google for breaching like standard conformance on Java and writing their own headers or something of this nature. I don't remember exactly all the details. But whatever the case is, that Java, I think, I think initially it was moving in a direction where it had good intentions, but it was still sort of owned by a company. And this can be dangerous when you're developing any piece of software for the language that you choose, because you don't necessarily want your video game to be controlled by the whims of some corporation. And that corporation could be Oracle, or that corporation could be Microsoft. Now, I realize C# has also kind of broadened its horizon, or at least attempted to broaden its horizon. So it's considered more of an open thing. But in both of these cases, for C# and Java, I don't know that they are like fully open languages. In fact, let's take a look here. Is Java an open language for its standards body? Something like this. Let's see what it says. Okay, so it says Java and the open standards body. Yes, Java, through the Java community process, operates as an open language for its standards body. Okay, so we can get into all the details of this, but yeah, and here we go. It's important to note that while Oracle, the company that acquired Sun Microsystems, the original creator of Java, owns the Java trademark, the Java SE specification is not owned by Oracle, but is defined and governed through the JCP. Okay, that's cool. That's really good. And the reason why this is so important, again, is you don't necessarily want a corporation owning the programming language that you're going to write this massive game in, or this you're going to dedicate your life to, because then if that company decides they want to make a change with that language, they just change it. And if you happen to be using those features and they just got rid of them, there is no recourse. Whereas if it's a standards body, generally what happens is, yes, the language will likely evolve slower, but it's often the case that they won't do things like breaking backwards compatibility. It's not to say that they are disallowed from doing that. I think there are cases where it could do that, especially if there are known security violations. But generally speaking, I think they're trying very hard to protect their community and make sure that people don't have to rewrite all their code because they do some sort of update. Now let's drop C# in here and ask if this is basically the same situation. Okay, so it says for C#, yes. Yes, C# is an open standard managed by the ECMA, European Computer Manufacturers Association, and ISO, IEC, International Organization for Standardization, International Electrotechnical Commission. Okay, now, more specifically, standardization. The C# language specification is standardized through ECMA International, specifically ECMA 334. This standard allows for independent implementations of the language. ISO adoption. ECMA submitted the C# standard to the ISO via the fast track process, and it was adopted as an international standard in 2003. Okay, that's cool. Open source development, while originally a Microsoft developed language, much of the C# ecosystem, including the Roslyn compiler and the .NET Core runtime, is now open source on GitHub. The community, the C# language design evolution process happens in the open on GitHub, where community members can participate in discussions, propose features, and contribute to language development. In short, C# is an open language in the sense that its specification is openly available and managed by a standards body, allowing for multiple implementations and community involvement in its development. Okay. Now, this one is a little bit different to me than Java because I'm seeing some things that I don't totally love. And I don't want to go down this rabbit hole, at least not in this discussion, but let's consider just this last point. All right. Community contributions. The C# language design and evolution process happens in the open on GitHub. Who owns GitHub? Microsoft does. Who created the C# programming language? Microsoft did. I'm already not getting warm and fuzzies. And hopefully you can see why. Now, this is not to say anything bad about GitHub or anything bad about Microsoft. This is purely trying to make the point that when you have bindings of programming languages too close to the corporations that created them, things can start to get very political and usually not in your best interest as a developer of a video game or a program. It's more in the interest of what's going to be good for Microsoft or whatever company. Again, I'm not trying to pick on Microsoft here. I'm just trying to draw the parallel of be careful what language you choose, especially if it has strong correlations with some company that invented it. And it sounds to me like Java is a bit more open based on what we saw. It sounds like both of these are supposedly open-ish, but again, I if it were me, I would do more research, and I still like C++ because it's on its own, it's its own thing, and nobody really claims any kind of ownership. I mean, if anybody would, I think it would be like AT&T or Bell Labs or something. Okay, so hopefully this gives you some insight into these top three things. So we have C++. This is the language that if you really want to be just a super developer, obviously I have some bias here because this is the language that I principally code in. But what I can tell you is I kind of code in I don't know, 15 different languages. Like, I don't even really care. Because as I was saying before, and I don't mean this like whimsically, I mean that, again, if you can master, it's sort of like if you can master partial differential equations in calculus, I'm pretty sure you can do basic arithmetic. I'm pretty sure you're going to be able to do trig or geometry or whatever. So it's like similar here, is that if you can master all of the craziness of C++, everything else is probably going to feel really simple, because it's not going to give you the crazy and awesome and dangerous power that you'll get from C++. So with that said, these first three languages, I think, are the key ones that you may want to consider if you're going to do a game and you want to have things be relatively fast. My recommendation, if you want things to be like, have the ability to potentially be extremely fast, it would be limited to these two languages, not Java. And there's a very like simple reason for this, is that both C# and C++ essentially allow you into unprotected mode, where you can do some really crazy things if you need to. The last I checked, you couldn't do this in Java, and maybe you can now. And I know that you have like the JNI, the Java Native Interface, I think is what that is. What does JNI stand for Java? What is it? A Java Native Interface. Okay, so you have this JNI thing, and that does allow you power, because then you can dive into stuff like this, which can be helpful. So if you do get stuck, there's ways out to make it screaming fast. But anytime you have to like exit out of the language and kind of enter into this other space, I've done this before, which you could probably tell because I sort of know about this JNI thing. But you're adding more stuff. You're adding more ingredients to the thing that you're cooking. And too many ingredients can make it very hard for you to kind of grok all the stuff that's going on. Whereas in C and C++, habit. Whereas C++ and C#, you can essentially stay in those languages and just be like, okay, I'm going to go crazy here. Be like, all right, I'm going to go and start using raw pointers right here. And in C#, you basically say, okay, unprotected mode, let's get wacky. Now, one slight downside for both C++ and Java that C++ does not have to carry around with it is you don't need a runtime environment for C++. But again, to my recollection, and at least when I was fiddling with these languages last, you need a runtime engine to support these, because Java does its just-in-time compilation and it'll translate its Java bytecode into something that's more performant for that architecture using that runtime system. And similar things will happen with C# using the .NET runtime environment. The point is that runtime environment is going to incur overhead. And what it does is outside of your control. You don't have any control over that. So if you don't like the speed of the garbage collector, you're out of luck. It doesn't matter if you don't like it. And therefore, you would have to write like your own memory manager to do better. And that's why you might use this. Now, again, writing like your own memory manager, this is not for the faint of heart. This is some Jedi Master level stuff. And it's not going to be something that you master in a weekend. It's likely going to take a while. While we're on this topic, if you're interested in things like memory management and performance, I strongly recommend this book. This book here, Efficient C++. I read this a long time ago. 20, 20 years, maybe something like that. And I learned a lot by reading this. So there's probably more up-to-date books. I don't know if this has been maintained over the evolution of C++. So it looks like I don't think const expressions were part of the language when I was first messing it. Maybe these guys were the unique and shared pointers. Maybe they weren't. Anyway, yeah, it looks like there's some updates since when I originally read it, which is great. But if you are not a master of C++ and you want to get better because you're compelled now to write your video game in C++, this would be a really good book to read. And my recommendation is to read this book and read it very slow. Don't try to race to the end. There's some very advanced things in this book. And if you implement some of the things that they talk about, like the memory manager, as I think I did, you're likely going to start to really hone your skills to be able to build something that is essentially your garbage collector, right? Except it can be invoked the way you want it to, and it can have deterministic rather than sort of non-deterministic execution, which is very common for managed languages that just invoke the garbage collector whenever they want, and then you have potentially some stalls or stutters. And garbage collection is not the only thing, but that's definitely one of the big things that is a huge benefit to these languages. So it makes your life so much easier when you have a memory manager, and it's going to make sure that things get deleted properly and all of this fun stuff, and do reference counting for you, so on and so forth. But at the same time, there's no such thing really as a free lunch. So if you head down this path, there are costs to these benefits. And one of the biggest costs is unpredictable performance. And for video games, just to be totally clear with you, Linus Torvalds and myself, I think we both would argue, I think he argued once and I've argued more than once, that two of the types of systems that perhaps are the most demanding in terms of bare metal performance, where people really, really want performance, and if you don't give it to them, they're going to be like mightily unhappy. The two areas that this tends to be like the most obvious, I would argue, are video games and operating systems. If you write an operating system that's slow, everything else is slow. It'll just be sluggish throughout, and then people are probably not going to be super thrilled. You want it to be smooth as butter. Same with video games. If your core engine of the video game is slow, everything else generally is slow. The movement is slow. The monsters are slow. Like, it's just not great. So if you're building those two things, you generally want to use the programming languages that are going to get you the closest to the metal and then still allow you to build largely scalable software systems, which in my mind falls into the space of C++. Okay, now moving beyond these top three that are like considerations for things like AAA games or things that are going to have graphics. Now we get into some of these other languages like JavaScript, Python, and Lua. For these languages, I would argue that you can build games in them, and it's likely going to make your life significantly easier if you write games in these languages because they can handle a lot of the heavy lifting for you. But you're not likely to build something like Elden Ring or Baldur's Gate 3 or Cyberpunk or Death Stranding 2 in these languages. And the reason for that is just very simple. When you are writing code in languages that are essentially fully scripted or fully interpreted, it's very rare that you can get anywhere near the performance that you can get in these like compiled languages. So what I mean by compiled here is that it's going to do some stuff in this first phase of compilation that could make the performance really fast, depending on the compiler, or reasonably fast and turning it into an intermediate representation that's like a bytecode that's portable. So whatever like the native portable bytecode is for C# that runs in the .NET runtime system, and similarly for Java, the JRE or something. Is it the, yeah, right, the Java runtime environment. Okay. I'm looking this stuff up mostly not to like flex that I'm right. I'm mostly just trying to remember because it's been a while since I've done some heavy lifting in Java. So with that said, going back to these scripting languages like JavaScript, Python, and Lua, and by the way, I've coded in all of these languages. I actually absolutely love Lua. I mean, it's super powerful and it's crazy dangerous, but it's pretty interesting. And I actually, before I was the director of engineering at Machine Zone, I was actually writing Lua code for one of the games. And this is when I kind of fell in love with Lua. I quite like it. However, I think Python is more well-known in terms of people I think are more familiar with it. On top of that, it has a ton of packages and things that you can import that are going to make your life easier, like being able to do regular expression, like super easy, and other types of things like socketing and all of this stuff. And then, of course, there's JavaScript, and JavaScript has the huge advantage that it basically is going to run natively in almost every browser. So if you're going to create a browser-based game that doesn't require huge amounts of performance, JavaScript. For me, it's a bit of a no-brainer. It's just JavaScript. But again, keep in mind, Elden Ring, Death Stranding 2, even Death Stranding 1, Path of Exile, all of those, Diablo, all those games, you're not likely going to write those games in a fully scripted language. I mean, maybe you could write the original Diablo today in something like JavaScript because it's sort of so dated and it's probably so basic. But if you were to try to rewrite, let's say, all of Death Stranding 2 in JavaScript and have it be running side by side to the actual Death Stranding 2 game, I suspect you're going to be 10 to 100x or more slower than, like, your JavaScript version would probably not even be playable compared to the actual game. And that's because that game, more likely than not, is requiring near bleeding edge hardware. So close to the bleeding edge for GPUs, some sort of RTX something or other from NVIDIA. I think I've got like a 3080. I think there's like the 40 something now. There might even be more than that on laptops at the lower end, and then the actual desktops is probably more than that. And then for the CPU, like whatever the latest and greatest is from folks like AMD or Intel. Now, while we're on that topic, I want to also share that, again, if you're writing games, you will often see that a lot of the games are written for Windows and not for the Mac OS. There's a whole history on why this is the case. A lot of it originally stemmed from things like DirectX and having stronger support for graphics on Windows. Now it's like, I think, an even more complicated story because the M processor is an ARM processor, which is fundamentally different instruction set architecture than x86. And like, I don't know. I'd have to look at it more deeply, but generally speaking, for operating systems, if you want to have desktop be your target, Windows is probably where it's at. It's not to say that you can't make it compatible on both. I think you can, both Windows and Mac OS, but there's likely going to be some trade-offs there. And you may not be able to build something that's like Cyberpunk 2077 or whatever the name of that game is. What is that? Sorry, my head's in a bit of a daze. There's tons going on. Yeah, 2077. Great game, by the way. I'm actually really enjoying it. So for desktop operating systems or non-mobile operating systems, trying to figure out the right word for this, Windows is generally the target operating system. And then again, for mobile, it's sort of wide open. There's many different things you can do. One of the things you can do with mobile is you can make it browser based. There's just a ton of stuff, and you can often get away with other higher level languages for mobile for a few different reasons. The first is the expectations of 50, 60 frames per second at 4K is not likely the default that people are expecting for like what they might be if it's AAA or console. Instead, they're just like, is it fast or something? Or is it playable on mobile? On top of that, even if you could make it all that, these systems are generally constrained by battery life. That they're not plugged into a wall that's giving them a constant power stream, like desktops or laptops or other systems are that are going to be built using some of these other languages. And so because of that, even if you had something that's screaming fast, you'd probably deplete the battery right away. And then it doesn't matter how fast it is because the mobile device only plays it for like 30 minutes and then dies. So with that, these other languages, specifically JavaScript, and maybe Go, and maybe Objective-C or something for iOS, I'm not sure. These types of systems may be more optimized because that's generally what's running, and so they may run in a way that might even be better if it's written in those languages for mobile than if it was written in like the lower language, the more powerful languages that can allow you to go lower level that you would see in traditional desktop and laptop operating systems like Windows. Okay. And then we've got a little list here on how it's breaking stuff down. Now, with all of that said, by all means, you do you. So whatever, if you want to write your game in Quick Basic and Fortran, have at it. You know, like I'm just trying to give high level on understanding the landscape and how these decisions might impact you in a really positive or negative way based on what you're trying to build. But ultimately, if your goal is just to get experience and dabble, it probably doesn't matter that much since this is going to be maybe more of a hobbyist thing. However, the counter to that, sort of the devil's advocate to that, is you might be surprised. You might end up building something like Nautica where that was just a toy hobby thing for me. And then it turns out that people really started playing it. Next thing I know, I've got 100,000 players and millions of monsters. And thank goodness I wrote it in a language that can be super fast. Otherwise, the system's not likely to scale to that. Okay. for now, let's have that be all we're talking about with programming languages. There's tons more to discuss, but I want to sort of nip it in the bud since I think we have the high level approach of how to think about this. Hopefully, we'll probably have more discussions about it. And then as we go deeper, I'll probably show examples of how to write stuff in C++. This also hopefully gives some insight into why I'm tending to look at C and C++ stuff. Is again, it's the wider range of things you can do and sort of the precarious situations you can get into. It's not for the faint of heart. But again, like, you can do some pretty powerful things. So don't just write it off just because it's powerful and scary. Yeah. All right. The next grouping are what I call data languages. Hey guys, sorry, I accidentally showed something I'm not supposed to show, so I had to stop and then restart. So I don't necessarily know how we got to this space of these things being called something else. I think that oftentimes people are calling these like markup languages, markdown languages, whatever. I don't really like this nomenclature. The way I like to think about it is there's sort of these two categories. And again, I don't think the world calls it this way, but I'm not sure that the world is calling it like the right thing. For example, JSON, I think this stands for like JavaScript object something or other. Let's actually go to, let's go to Perplexity. What does, and let's ask it. Okay, yeah, here we go. It stands for JavaScript Object Notation. Okay, let me be the first to share this with you. You can use JSON wherever you want. You could create a text file right now and have it be JSON. It doesn't have to use JavaScript. It's used all over. We have JSON files that are being read in and used for C++ and for our database and for all kinds of things, for Go. So I want to mention this because people sometimes are a bit lousy with names, and I don't mean that like in a bad way. Like I'm trying to be dismissive or speak down to them about like not caring. What I mean is that originally when this was created, as I understand it, this was principally for JavaScript. However, it's such a great format that we've kind of adopted it and we're using it everywhere. In fact, before JSON, I was using XML in a lot of places, but then JSON's just sort of more abbreviated and provides almost the same levels of safety guarantees that you get, I think, from XML. And so, and on top of that, JSON is understandable. It's readable. Whereas XML, sometimes you can read it, but it's just a little bit harder with all the tags. The point that I'm trying to make is that if you didn't understand this distinction of programming languages and data languages, and instead I just listed a whole bunch of stuff, you might think that JavaScript object notation is a specific thing for JavaScript and it has a direct binding to JS or TypeScript. It doesn't. And so the names of things are not always super great, but the way I think about these things is that these are essentially data languages. CSS is admittedly somewhat specific to things on like our browser or web pages. So we'll just limit it to JSON, XML, and text. But each of these three things, you could probably have Markdown maybe in here. And maybe even things like HTML, even though I think HTML is supposedly what a markup language. But again, like markup, markdown, I don't even know exactly what these words mean. In principle, the way I think about it is the code that you're writing or the thing that you're writing, is it being executed like instructions one after another, and that if you inverted the order of these things, everything would break. If it is, that's probably a programming language, in that you're writing in a language to create a program. And programs have instructions that are executed, usually in a serial fashion, at least some segment in a serial fashion, even if it's multi-threaded and asynchronous and all that stuff. That's a programming language, and that's why we call them programming languages, is that they're used to build programs, software programs. Data languages, what I call data languages, are languages that are not meant to create programs. They are meant to store data. That the principal purpose of these languages is to give you essentially a syntax and a structure, because these are both used in the space of what I'll call computer science, or in the space of software. But one is used for creating programs. The other is essentially an ancillary language that is used as auxiliary for the data that will be used for the program. So you can have many JSON files, for example, that your program in C++ will then read and do stuff with. Now, this is somewhat important. Just like the programming language decision that you're going to make is going to have massive implications and ramifications on the type of program you're going to build, the decision that you make on these things will likely have far-reaching implications on your game or your software system. It may seem as though they're easy to change, or it just doesn't matter, or whatever. I can tell you that my experience has been, when I've been somewhat laissez-faire about these decisions, like I made things entirely text, as I did for the first version of Nautica, things went bad in a very fast way that I probably never want to experience again. And I won't even bore you with the details. Maybe a later video we'll get into this. But if you have some sort of corruption in the text files, maybe not even from your fault. Like, for example, in Nautica, the characters can create their own descriptions. And I was using a text file that was expecting certain things to be a certain way. And one of the character descriptions decided to have a termination character in there that was a termination character that was like reserved. And then things went wacky, right? And then suddenly that player file is totally broken. Whereas if you use things like XML, you can almost guarantee that those things are avoided. I mean, obviously XML tags still have, some issues, right? So you need to make sure that these things are like disallowed, unless it's something like C data. And I forget the actual format of C data. It's pretty wacky. I don't know. We can look it up. And C data allows for things, I think, like that inside of it, because it has some weird escape, a termination signal that comes at the end of the C data. But you still need to be like very careful, I guess is what I'm saying. And I don't know exactly what JSON has. JSON may have something that is protecting people, but I don't know. Like, and what I'm talking about protecting people is, as you get into more complicated fields, you may have data that a user is providing, that you're tracking your JSON file, and if it has weird breaks, it could signal to the JSON system that the JSON tag, essentially the key and the value mapping that it thinks it has ended, because they've included a weird delimiter like a return character, and then suddenly your JSON is broken. So this is actually supremely important. You can also store things in directly in databases. But if you consider this, then just understand that that's a dependency that you may be carrying forward with you. It's not to say that databases are wrong. I think databases can be great, but they can be something that you're going to carry forward. So just understand the ramifications. That's why maybe starting with data files in data languages. Principally, I would recommend one of these two. XML, if you're going to have some weirdness and you want to be very sure that people can't break it, and then you can put stuff in C data and make sure they don't have the escape clause for C data in their metadata or whatever, and you should be okay. But if you know things aren't going to get too wacky, and the user isn't going to be able to potentially put strange things in there, JSON's probably easier. And it's easier to understand, it's easier to read. I also want to share that these data files that you're creating, I strongly recommend you make it so they are fully human readable. It doesn't have to be, maybe fully is the wrong word, mostly human readable. So if they have like passwords and stuff, you can encrypt that or whatever you want to do. But you likely will run into cases where you need to debug these files. And if you can't read them, it can be really difficult when you run into that bug that's breaking your system. And then you're trying to pull in the file because it's all in binary or something. And then the binary is corrupted and you have no idea what's going on. Because you can't read it, you can't understand where the issue is. And then the mechanism that you're using to pull it in isn't working. And so it could set you back. Now, the higher order bit of this whole discussion with these languages is just to understand that as you're building a game or some large software system, one of the first decisions you're likely going to have to make are which programming languages do you want to use and what data languages do you want to store your data in. This is predicated by the type of game that you're going to build, the type of like sort of industrial strength that you need it to have with the way the data is stored. And that's really for you to decide. My goal in this episode is really just to make you aware of these two categories. And no matter what the video game is that you're building, I mean, with the exception of something like super simple, like maybe Pac-Man, if you're going to build a video game that's going to have, I think, richness to it, you more than likely are going to have external data files, and those data files, if they're not stored in a database, are likely going to be in one of these forms, and this decision is going to creep up on you really fast. Like with Nautica, one of the first things that I wanted to do was create the character generator, character creator. Okay, so I create the character creator, and now I have to save the player file. All right, we're already there. There you go. Now you need to figure out how you're going to save it, and then how you're going to, what they call serialize and deserialize. You're going to serialize, and I can't remember, I'll probably get this backwards, but serialize is you're going to read it in, and then populate your character class or whatever, and then the opposite of that, deserialize, whichever way it is, you're now going to export that and then save that into a data file. I probably got those inverted. Maybe serialize is create the data file and deserialize. Who knows? But it's the process of essentially reading it in and pushing it out. Those types of operations, as you are building different components in the world, they are going to be happening likely in a number of places. So with Nautica, minimally, it's player files, mob files, the NPCs, item files, area files, the general player boards, clan files. Did I say item files? So you can see how this is going to get probably very big in a bunch of different ways very fast. So just as important as the decision it is for programming languages, the data languages can be quite important too. strong recommendation that you go with JSON or XML. And on top of that, most of the languages have built-in libraries now that you can load up, and then they'll do the parsing for JSON or XML for you, and it becomes super easy. You just say this is a JSON file, like pull it in, and then it's like, oh, I've got it, and then you can access it almost directly, like it's a hash map or something, the whole key value pair. And similarly with XML. Okay, cool. So that's basically all I wanted to give an update on today. I think next time we'll take a deeper look into the thumbnail generator, and you can see a variety of things that I've been adding to this that I think make it interesting and exciting. One of the things that I added is you can do stuff like you can up like a few of these different ones, and then down like then you can down like something, and then you can say generate more or less based on all of those, and then it will try to do something meaningful. So I can say have the combined image fighting a dragon. And then in theory, what it would do, if it does all this right, is it'll take this, and this, and then try to figure out what's common amongst these. Try to assemble this into something meaningful while eliding away this piece, and then adding in the elements that I included in the meta prompt, which is that it's fighting a dragon. So let's see. I think that it built the meta prompt, and it probably built this prompt. Yeah, so look at that. Like that sort of worked-ish. I mean, I'm not exactly sure. It turned it into a fairy, I think. And who's to say that that little flower wasn't on its way to becoming a fairy? I mean, maybe that's where we were headed. I don't know. But cool stuff, right? Obviously, still some bugs with the UI. I've been trying to sort some of those things out. And then, like you can see, this one was downvoted. I can unselect that. Anyway, and then I think I can clear these selections. Yeah, there's just a bunch of fun things that I've been adding to it. But I will also share that it's getting much more, it's getting much slower, and it's taking much longer to actually generate the code. And this is one of those cases where if it had a little bit more brains, which is why I was thinking about maybe up-leveling to something like Cursor or something else that hopefully can understand multiple files and push things like this into a CSS file so it doesn't like regenerate this. But again, my goal is with this vibe coding thing, I'm trying to see how much I can do purely with just like natural language and not requiring me to dig deep into the code. Because we could do that, but I'm trying to get a sense of like, if you didn't have the ability to code, what could you achieve with the whole vibe coding movement? Anyway, yeah, we'll discuss more of this next time. Thanks, everybody. And feel free to drop comments on if you think I should shorten the name of the channel from Goju Tech Talk to maybe just Goju Tech. Probably not Goju Talk or something else. I think Goju by itself is probably not sufficient. And I think someone has the Goju name on YouTube. So that might be hard. We'd have to like underscore it or something. But I think having a second word could be cool. But maybe it helps us drop that third word. I don't know. I'd love to hear what your thoughts are. Very seriously, because I kind of just want it to be shorter. And yeah, we'll see. So thanks, everybody. Hope you're having a great week. And keep on keeping on.